History remembers the massive Saturn V and the spider-shaped Lunar Module, but the real lifeline was the command and service module. Orbiting silent hundreds of miles above the surface, it was their command center and their anchor. It never touched lunar dust, yet it was the mission's beating heart, and the only ship built to bring them home alive. Strangely enough, the CSM wasn't originally conceived for a lunar voyage at all. Its roots stretch back to 1960, 1 year before President Kennedy challenged America to go to the moon. NASA's earlier request was for a spacecraft meant to support a massive rotating space station called Project Olympus, but when the lunar mandate arrived in 1961, the entire concept was scrapped overnight. By the end of that same year, North American aviation was already developing a lunar spacecraft. Before the Saturn V had its final three-stage configuration, and before the Lunar Module even existed. The spacecraft had to evolve instantly, and from that pivot came two distinct versions. Block 1, a prototype meant only for Earth orbit, and Block 2, the fully realized machine capable of going to the moon. The CSM was built to keep a crew of 3 alive for up to 14 days in space. Despite its massive complexity, the command module was designed to be flown by a single astronaut if necessary, a fail-safe in case the worst happened. The inner pressure vessel used thin aluminum sheets bonded to an aluminum honeycomb core. On the outside sat stainless steel structure, also using honeycomb support. Between them, fiberglass insulation, resulting a structure that was light, rigid, and heat-resistant. The most critical part of the ship was also the part designed to destroy itself, the heat shield. Manufacturing this was a painstaking manual process. Here, a honeycomb structure made out of fiberglass was used to cover the metal base, and technicians had to fill each individual honeycomb cell by hand, with a material called AV coat. Filling the thousands of cells took 6 months to complete. Then a cured AV coat layer containing tiny air pockets created a lightweight thermal skin. And above that were the final protective coatings, including the silver-looking mylar layer also used on the Lunar Module. The handmade shield had one job: to burn. Hitting the atmosphere at high speeds, the shield didn't just block heat, it managed it by destroying itself. It charred, cracked, melted, and vaporized, carrying the heat away from the capsule. While the outside heated to metal melting temperatures, the astronauts inside stayed safe. By the time they splashed down, 5 to 10% of the spacecraft's total weight had simply vanished. Inside, the engineering was just as clever. The crew couch hung on 8 struts connected to the frame, acting as shock absorbers. The positions of the struts were engineered in such a way that they would absorb forces in any direction. But beneath the floor, aluminum ribs were designed as a crumple zone, placed slightly off-center on the side where the capsule leaned after the parachute deployment. If the parachutes failed or the seas were rough, impact loads could spike to 40 Gs on the capsule. These ribs were made to collapse and crush, absorbing the energy so the astronauts wouldn't have to. The CM had 5 windows, and each had 3 layers, 2 inner pressure panes and a thicker outer pane. This outer glass could withstand much higher temperatures without shattering and had UV reflecting coatings. The command module had 2 hatches, the large side hatch for entry and exit and the forward hatch for transfer to the Lunar Module after docking. Both could be opened from inside or outside, and both used gas-powered pistons for assistance. And if anything failed, they could still be operated manually. Attached to the back was the service module, housing most of the spacecraft's consumables and its main propulsion system. Soon after reaching space, the CSM performed its first major task. It separated from the Saturn V third stage, rotated 180 degrees, and then docked with the Lunar Module. Once locked together, the CSM pulled the LM free, forming the complete spacecraft that would carry the astronauts all the way to the Moon. And interestingly, when the Lunar Module descended to the surface, one astronaut remained in the CSM. Floating alone in the lunar orbit, cut off from Earth communications while on the dark side of the Moon, the command module pilot became, quite literally, the loneliest man in the universe. After the Lunar Module lifted off and the crew reunited in orbit, the journey home began. Before re-entry, the service module had to be discarded. To do this, the CSM used the pyrotechnic guillotine, a controlled explosive device that physically sliced through the wires and connecting tubes in an instant. After surviving re-entry, the landing system took over. It wasn't a single parachute, but a chain of 9. The first deployed to jettison the forward heat shield, 2 drogue chutes stabilized the capsule, 3 pilot chutes deployed the mains, and finally, 3 massive main parachutes carried the crew safely to the ocean. After splashdown, inflatable flotation bags deployed and righted the capsule while they waited for recovery. The command module story was shaped by both innovation and loss. The Apollo 1 fire claimed the lives of the crew during a pre-launch test and prompted comprehensive revisions that produced the safer, more resilient Block II spacecraft. The CSM proved its strength during Apollo 13, when an explosion in the service module crippled the ship.
Okay, Houston, we've had a problem here.
The command module was powered down to a freezing shell, then brought back to life only moments before re-entry. And during Apollo 15 descent, one of the 3 main parachutes collapsed, resulting in a harder splashdown. Even so, the capsule held firm, keeping astronauts safe. The Lunar Module gets the glory and the Saturn V gets the fame, but the command module was the shield, the home, and the lifeboat that carried every Moonwalker safely home. It never landed on the Moon, yet it carried every risk and every dream across 250,000 miles of void. So which piece of Apollo engineering you liked most? Share your favorite in the comments.